Good day, I'm Tapela Matula, and I'll be taking you through the following presentation. The presentation focuses on four main topics. The topics are 1. What is the effect of pesticide residual in the environment? 2. How do filtration membranes in wastewater purification work? 3. What are the environmental problems associated with phthalates? And lastly, 4. Discuss how wastewater byproducts can be reused. This presentation was compiled by K.A. Motiang, M.M. Weber, T. Madula, M. Kaba, T.C. Makola, M.K. Lesinyeho, N.P. Mdluli, and N.P. Jaza. The first topic of discussion will be, what is the effect of pesticide residual in the environment? Firstly, what are pesticides? Pesticides can be explained as chemical or biological substances that deter, incapacitate, or kill pests. These substances can vary from virus, bacteria, antimicrobial, and/or disinfectants. In layman terms, pesticides are poisonous chemicals that are used to destroy pests. There are different types of pesticides, and these pesticides are grouped according to their targeted pests. Firstly, we'll look at insecticides. Insecticides target mainly insects, and they are used in public health sector, industrial, and domestically. Secondly, we look at herbicides. These target plants, and they are used in agriculture and wildland ecosystem as to reduce the density of weeds and promote the growth of desired plants. Thirdly, there are rodenticides. These target rodents such as rats and mice. These are used in agriculture and also domestically to kill mice and rats among other rodents so that the population can be reduced. Fourth are fungicides. Fungicides are used to prevent crop damage by fungi as to protect the harvested products. And lastly, larvicides. Larvicides are used domestically as to control mosquitoes in and around homes. Pesticides residual. This refers to the contents of the pesticides that are either found on the ground, in the air, and/or on fresh produce. In the South African context, a study that was carried over a period of 5 years, between 2009 and 2014, concluded that there are 4 common pesticides residual that are found in fresh produce in South Africa. Namely, they are imazolil, prochloraz, iprodione, and diphenylamine. The aforementioned pesticide residuals are relatively harmless, and in general, the effects of pesticide residuals on the environment gradually decrease over a given period of time. But nonetheless, their presence in the environment may negatively impact the biological diversity and human health. Now, on to the next topic of discussion. How do filtration membranes in water purification work? Now, looking at both ultrafiltration and microfiltration. These two methods remove particles from water by using membrane. These methods are similar to that of traditional sand or media filters in that they remove suspended material but not dissolved solids. These methods can be done under pressure or under a vacuum. Both these methods are used for the removal of germs and viruses from wastewater. Membrane filtration is a method commonly used to remove dissolved chemicals and tiny particles from solutions, and can also separate and concentrate colors from effluents on a continual basis. The method's characteristics include tolerance to temperature changes, harsh chemical conditions, and microbial death, and it is very useful for the treatment of effluents having low quantities of dyes and the recycling of textile wastewater. But the method is quite ineffective for lowering dissolved solid content, which makes water reuse problematic. Water purification. Water purification is a process where unwanted chemical compounds, organic and inorganic elements, and biological pollutants are removed from water. This process is very important because it improves the flavor, smell, and appearance of water while also removing hazardous contaminants. There are 4 categories of membrane filtration used in water purification, namely, they are reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. For reverse osmosis, firstly we need to understand what is osmosis. Osmosis is the natural propensity for solutions with different salinities to neutralize each other. Pressure is used in reverse osmosis to overcome the natural propensity of clean water to pass through a semi-permeable membrane, while salts and other dissolved solids are concentrated on the feed side of the membrane. Now on to nanofiltration, which is also known as membrane softening. Nanofiltration works in the same way as reverse osmosis, but the semi-permeable membrane is looser, allowing some salts to pass through while rejecting bigger dissolved molecules, including hardness, organics, and color. A practical example for reverse osmosis is the desalination of seawater. Now, let's discuss how wastewater byproducts can be reused. Firstly, let's understand what is wastewater. Wastewater is the water that has been used in homes, businesses, or as part of an industrial process. This type of water can be recycled through water treatment methods so that it can be used again. Some of the common byproducts that are extracted from wastewater during the wastewater treatment process are biosolids, biogas, and hydrogen sulfide. Biosolids. Biosolids are materials generated from the treatment of sewage sludge. They are very rich in nutrients such as nitrogen, potassium, and phosphorus, hence they serve as fertilizers. For the generation of biosolids, wastewater undergoes trash removal, settling, digestion, and the dewatering of the biosolids. Biosolids are very useful in agriculture, as they can be used for land reclamation, landscaping, forestry, as retail fertilizers and debris biosolids. Besides being used as fertilizers, biosolids can be dried and be used to feed certain animals. Biogas. This illustration shows the different ways that biogas is generated and the different applications for biogas after being processed. And the last topic of discussion is, what are the environmental problems associated with phthalates? Firstly, let's understand what are phthalates. Phthalates are a group of man-made chemicals that are mainly used to improve the flexibility and make plastic durable and soft. They have been in commercial use since the 1920s. They can be used as plasticizers and solvents in product manufacturing. Common phthalates include dibutyl phthalate, diN-octyl phthalate, diisononyl phthalate, and diethyl phthalate. These phthalates can be readily biodegraded and mineralized. Phthalates are colorless, odorless, and oily liquids that do not evaporate easily and chemically bind to materials that they are added to. Phthalates are found in everyday products such as food packaging, fragrance, toys, and shampoo. Now, looking at both ultrafiltration and microfiltration. These two methods remove particles from water by using membrane. These methods are similar to that of traditional sand or media filters in that they remove suspended material but not dissolved solids. These methods can be done under pressure or under vacuum. Both these methods are used for the removal of germs and viruses from wastewater. Ways to limit or avoid exposure to phthalates include: avoid using products that contain phthalates red labels. Store food and drinks in glass, stainless steel, or ceramic containers instead of in plastic containers. Avoid purchasing plastic items made of PVC. Use an alternative plastic that do not require phthalates such as bio-based plastics. Never reheat food in plastic containers. Avoid sucking or chewing soft plastic or vinyl products. From the compilers of this presentation, we thank you for your attention and have a good day.